Okay, so I'm recording a video for the question that Nicoletta asked yesterday in class, and I said I wanted to do this via video. But I will tell you, there's going to be a little bit of background noise. I've got a son over here who's making a smoothie, and my wife is sitting right next to me sewing her stuff. So let me put the sewing machine down and say, Jill, why don't you say hi to everybody?
Hello.
Okay, so you're going to hear that sewing machine going here in a second. And I just ask you to just bear with me. Okay, so just a second here. Gotta get this camera right. All right, so the question is from the homework problem set. Homework problem set from the chapter is question number 1. Okay, homework problem number 1 from the homework sheet. Okay, so I think this is the exact one she asked. I'm afraid to say I didn't write down which it was, but the question is, what is the minimum uncertainty in the position, okay, of a bullet? And then we've got some other things here. All right, so a bullet with a mass of 5.0 grams, and then a speed somewhere between these velocities here. All right, so when you see uncertainty, there's a couple ways this question could be asked. It could be calculate the minimum uncertainty, or in this case, what is the minimum uncertainty? And if you haven't done problems like this before, you're first of all going to look at that and go, oh man, I have no idea what the question is asking. So what I'm going to do, supposing I had no idea, so I'm going to say, well, I don't know that, but I do know this, that the Heisenberg uncertainty principle is delta x delta p over h bar, is greater than or equal to h bar over 2. So at least I've got something I can work with mathematically. Now I'm going to interpret the question itself, and I see that the bullet's got a mass of 5.0 grams. I'm not sure what that's doing yet. And then it's got a speed, which I'm going to call v for velocity, somewhere between these two amounts. So, alright, mv, alright. I'm starting to get a little bit of orientation here. M times v is p, so maybe we'll have something to do with that in a second. Oh, actually, this is delta v, right, because it's a range. So delta v is equal to 350.123.121 minus 350.123.123. Okay, so this is 1 times 10 to the negative 6, right? If you just subtract these two numbers, you'll see. That's the only difference right there. 1, 2, 3, 4, 5, 6. So it's 1 times 10 to the negative 6. Delta V is that. Okay, I'm starting to get a little better feeling about this problem, because the question's asking what's the minimum uncertainty in position. So I'm going to come over here and go, position, the minimum uncertainty in position, or delta x, is greater than or equal to h bar over 2 delta p. And this is starting to come together now. I can see that delta p is going to be m delta v, right? So this is going to be 5 times 1 times 10 to the negative 6, 5.0 times 10 to the negative 6. Oops, I started to say kilograms meters per second, because that's the units I want for momentum, but this was in grams. And you know how I typically will convert this immediately to equals 5.0 times 10 to the negative 3 kilograms. I typically do that when I'm writing my key out in the beginning, so that I can avoid this kind of problem in the end. So it looks like it's 5.0, and I didn't incorporate that times 10 to the negative 3. So I'm going to change this times 10 to the negative 9. Okay? I'm afraid that was a little clumsy. You should go through and calculate this yourself, though, and you'll find that you get that number. Okay, so it looks like I have everything. All I've got to do now is simply put in h bar. I always forget what h bar is, but I remember h. H is equal to 6.626 times 10 to the negative 34 joule seconds, and h bar is equal to h over 2 pi. So we'll calculate, oh, you know what, I remember what it is. 1.055 times 10 to the negative 34 joule seconds. That's what h bar is. You know, of course it's ridiculous. You don't need to remember this. This will be on the front of your exam or your quiz, or you can always ask what that is. Nobody memorizes these numbers on purpose. So 1.055 times 10 to the negative 34 joule seconds over 2 times 5 times 10 to the negative 9 kilograms, times meters per second. Okay, so this goes to 1.055 times 10 to the negative 34 joule seconds over 10 times 10 to the negative 9 kilograms meters per second. You know what, I'm just going to do this in my head, right? Is greater than or equal to, that's 1 times 10 to the negative 8, and negative 34 over negative 8 is going to give negative 26, so it's 1.055 times 10 to the negative 26, and it's delta x, so it's going to be meters. And that's the answer. You ought to prove this to yourself, that joules, seconds cancels out. I mean, what I'm going to do, I am going to prove that to myself. So always, joules is equal to, or energy is equal to 1/2 mv squared. Right? So that's the definition of joules, because E is equal to 1/2 mv squared. So if I do this in units, there's my joules. And so these units over here were joules, seconds, over kilograms, meters per second. And a joule is a kilogram. Here's my joule here, okay? Second squared over kilograms, meters. I'm just taking this and rewriting it down here, but I'm writing this, a different version of joule in here. Meter squared over second squared. Okay, I can see my seconds cancel, my kilograms cancel, and one of my meters cancels, which is what I wanted. Okay, so that's the answer for what is the minimum uncertainty in the position. Go through and do this problem again if you didn't like it the first time, and make sure that you're good with the wording, because the wording is something that I'm not going to help you with on the quiz or exam. It's something that you've got to be comfortable with, and it's probably the hardest part. Clearly our math was just algebra. But what does the wording? It's clumsy, isn't it? Or I should say abstract. Okay, best wishes. Hope that's helpful.